Welcome to The Explainer. We're here to break down big topics, and today we're diving into the world of AI engineering. We're going to make it crystal clear.
So, have you ever wondered how an AI goes from being a kind of general know-it-all tool to a super specialized expert? Well, answering that question is exactly what AI engineering is all about. It's the craft of turning raw AI potential into something that's actually useful in the real world.
And what that really boils down to is this. You're not building the AI from the ground up. Instead, you're taking these incredibly powerful pre-trained models, think of them like off-the-shelf brains, and then you're carefully adapting them for a very specific job, like a customer support bot or a handy coding assistant.
Now, this is a really key distinction to make because a lot of people mix this up. AI engineering is not the same as machine learning engineering. The machine learning folks are the ones in the trenches, building and training these massive models from scratch. AI engineers, well, we jump in right after all that hard work is done, taking those existing models and figuring out how to put them to work.
All right, let's get into the nitty-gritty. We're going to start with the most fundamental piece of the puzzle, the core building block for pretty much any modern AI application. And that building block is called a foundation model. Here's the best way to think about it. Imagine you just hired a new recruit who is an absolute genius. Seriously, they've read basically the entire internet. So they have this vast general knowledge, but they don't know the first thing about your company or the specific job you need them to do.
Now, the kind of foundation model you've probably heard the most about is a large language model, an LLM. Its entire skill set comes from one simple but incredibly powerful ability. It has gotten so good at predicting the next word in a sequence, and that one skill is what makes it an expert at summarizing, translating, and answering all sorts of questions.
So, what's the secret sauce behind all these powerful LLMs? It's something called the transformer architecture. The really clever part is its attention mechanism, which lets every single word in a sentence pay attention to all the other words around it. This is how the model understands context, even in really long, tricky sentences, and it's why its answers feel so coherent.
Okay, so we've got our brilliant new hire, our raw model. Now what? You can't just let them run wild, right? The next, crucial step is all about controlling its behavior and shaping its personality for the job you have in mind.
So how do we do that? We do it by adjusting things called hyperparameters. Now, it's super important to get this straight. There are parameters and there are hyperparameters. Parameters are what the model learned on its own during training. That's its internal knowledge. Hyperparameters, on the other hand, are the knobs and dials we get to turn to control how it behaves.
And one of the most important of these dials is called temperature. You can totally think of it as a creativity dial. Turn the temperature way down, and the model's answers become very safe, predictable, and factual. But if you crank it up, it gets way more creative and surprising, which is perfect for something like brainstorming.
And of course, the most direct way we shape the output is through prompt engineering. Now, this sounds super technical, but it's really just a fancy way of saying giving the AI really good directions. The clearer your instructions, the better your results. Simple as that.
This can be as simple as just asking a question directly. That's called zero-shot learning. But for much better and more consistent results, you can provide a few examples right in the prompt to show the model exactly what you're looking for, and that's called few-shot learning.
But what if great instructions just aren't enough? I mean, sometimes our new hire needs specialized knowledge that it just couldn't have picked up from reading the public internet.
We've got two main ways to handle this. The first is fine-tuning. This is like sending your employee for an intense, specialized training course. You're permanently retraining the model with new data. The other method is retrieval augmented generation, or RAG. This is more like giving your employee access to the company database so they can look up fresh information on the fly. So here's how RAG actually works. And it's pretty slick. When you ask a question, the system first goes and retrieves relevant facts from a knowledge base. Then, it stuffs those facts right into your original prompt before sending it to the LLM. This simple step is an absolute game changer for preventing the AI from just making things up and making sure it can be trusted with your real, up-to-date data.
Now, these models are massive, so engineers have a whole bag of tricks to make them more practical. They can use quantization to compress a model and make it faster. They can use distillation to train a smaller, nimbler student model that learns from a bigger teacher model. And they even use human feedback to fine-tune responses and teach the model to be more helpful and safe. Okay, so our AI can think, it can talk, but what about doing things? This is where AI engineering gets really interesting, when we start to let the AI take action out in the real world.
And this is where agents come in. An agent is an AI that can take a complex goal, break it down into smaller steps, and then use external tools like a web search, a calculator, or your calendar to actually get the job done.
You know, when a model generates an answer, that's called inference, and it usually comes in two flavors. There's online inference, which is what you see with a chatbot. It's got to be fast, it's got to be real-time. Then there's batch inference. That's for the huge offline jobs, like summarizing 1 million documents overnight, where efficiency is way more important than speed.
So finally, after our AI application is all built and running, how do we actually know if it's any good? Well, it's time for its annual performance review.
One of the most common ways to do this is with model benchmarks. You can think of these like standardized tests for AIs. They score and rank different models on all sorts of skills, which helps everyone track progress across the entire industry.
And for more specific tasks, researchers use automated metrics. For example, a metric called BLUE is great for judging translations by comparing them to a human one, and another one, called ROUGE, is used for summaries, just to check if the model actually captured all the key points.
So if there's one thing to take away from all this, it's this. AI engineering is less about building models from scratch and way more about the art of skillfully assembling and shaping these incredible tools to solve real problems.
So think about it. We've just walked through how we can build, shape, and even grade AI. We have this incredibly powerful toolkit right at our fingertips. Which leaves us with the biggest question of all. Now that we have the tools, what problems should we choose to solve next?